Hello everyone. I hope you've had a lovely 24 hours. Let's go ahead and dive into some more word problems with our law of sine and cosine applications. Yesterday we worked with our formulas for finding the area of triangles using either 1/2 AB times the sine of C, or Heron's formula, the square root of S times S minus A times S minus B times S minus C, where S was your semi-perimeter found by adding all your sides together and dividing by 2. Well, today we're actually going to use the law of sine or the law of cosine to solve some word problems. So you should have in your hand a worksheet that has your examples already typed up for you. So in your notes, what we're going to do is when we go to work them out, we'll just put like E1 for example 1. And since they're already printed out for you, we're not going to rewrite them. Okay, so let's look at this first example right here. Alright, we're given Juan and Ramela are standing at the seashore 10 miles apart. Okay, the coastline is a straight line between them. Both can see a ship in the water, the same ship at that. The angle between the coastline and the line between the ship and Juan is 35 degrees. The angle between the coastline and the line between the ship and Ramela is 45 degrees. How far is the ship from Juan? What area is covered between the people and the ship? Alright, so coming right here. Alright, we know we're going to have a triangle. So let's just go ahead and draw a triangle. It can be any shape. We've got Juan and Ramela, and then we got the ship. Okay, and let's see. Let me see if I can draw a little ship here. Oops. There's our little ship. Alright, it says that Juan and Ramela are standing at the seashore 10 miles apart. So what's the distance between Juan and Ramela? Well, it's 10 miles. Okay. Alright. The angle between the coastline, so here's the coastline, because that's where Juan and Ramela are standing, and obviously the ship's out there in the sea. The angle between the coastline and the ship and Juan is 35 degrees. So from the coastline to Juan and the ship is 35 degrees. The angle between the coastline and the line between the ship and Ramela is 45 degrees. So this is 45 degrees. How far is the ship from Juan? Alright, so we want this length right here. Alright, so we got two choices here. We got law of sine or law of cosine. For law of sine, we need an angle and the opposite side. Well, I think this is going to be law of sine, because even though we don't know S, we know enough of the angles to find this. What do all three angles add up to be in a triangle? Well, all three angles in a triangle add up to equal 180. So we're going to come right here, we're going to say 180 minus the two angles that were already given. 35 plus 45. Let's see, that's what? 80. So 180 minus 80 is going to give us 100. So this angle right here is 100. Now we have an angle and the opposite side. Whenever you have an angle and the opposite side, we know that we can use law of sines. So as we talked about, this was angle, side, angle. So angle, side, angle. And we had enough information given to us that we could find this missing angle. So now we got an angle and the opposite side, so we can use law of sines. So I'm going to come in here and I'm going to say the sine of 100 over its opposite side of 10. We're trying to find x, so we're going to use angle R. It's equal to the sine of 45 over its opposite side of x. This is a proportion, so we're going to cross multiply. We're going to say 10 times the sine of 45, and that's going to be equal to the sine of 100 times x. Well, we want x to be by itself, so we're going to divide by the sine of 100. Now, one important thing, make sure that when you go to Desmos, what mode should this be in, since we're actually dealing with trig? We're dealing with sine, cosine. It should be in degree mode. Now, I've already got mine in degree mode because I was working with it earlier, so we got it in degree mode. Any calculator that you use, you want to make sure it's in degree mode if you're working with sine, cosine, and even tangent. Okay, with triangle trig. Alright, so coming right here, these will cancel out. I'm going to have to put this in right here. So I'm going to say, got my division to bring up my fraction bar. 10 times the sine of 45 over the sine of 100. Alright, since this is a side, let's round to the nearest tenths. So here x is going to be approximately 7.2, and I think it was miles, wasn't it? So let that marinate for a few seconds. All right, move into example 3. So we're going to come right here in our notes and we're going to put E3. All right, Tom, Dick, and Harry are camping in their tents. If the distance between Tom and Dick is 153 feet, the distance between Tom and Harry is 201 feet, and the distance between Dick and Harry is 175 feet, what is the angle between Dick, Harry, and Tom? Oops, and find the area. I forgot to find the area up here, didn't I? So let me get back and find the area up here. Sorry, my bad. Try to get a little ahead of myself, didn't I? All right. Okay, so let's see. Come back here. We got 7.2 right here. All right, so for this one, since I now have side, angle, side, instead of using Heron's formula, I'm going to use the formula that we started off using, 1/2 A times B times the sine of C. I keep wanting to write cosine. I don't know why. So if I accidentally write cosine, know that it's supposed to be sine. If you forget, just look back at your notes from yesterday, but it's supposed to be sine. All right, so we'll come right here, we're going to say 1/2. All right, one of our sides, 7.2, times the other side of 10. Okay, so think about what we've used. We've used this right here. We've used this right here. So the angle of the side that we've not used is this one right here, the one in between. So it would be times the sine of 35. Okay, so coming right here, we've got 0.5 times 7.2 times 10 times the sine of 35. All right, and that gives us 20. Did it say round to anything? Nope. Let's do one decimal, so that's going to give us 20.6. So 20.6 miles squared, or square miles. All right, so going back to example 3. All right, again, we're just going to draw a triangle. We got Tom, Dick, and Harry. All right, so let's see. Between Tom and Dick, we've got 153. Between Tom and Harry, we've got 201. And between Dick and Harry, we've got 175. What is the angle between Dick, Harry, and Tom? Okay, so basically it's asking us to find all of the angles. So what I usually do is I usually start with the largest angle. Okay, the largest angle is going to be opposite the largest side. So that's going to be this one right here. we don't know any angles at all. So this is a side, side, side scenario. It would be helpful if you could see it, right? This is a side, side, side scenario. So we know that we don't have any angles, so it can't be law of cosine. Law of sines, it's going to be law of cosines. So we're going to come right here, and we're going to say 201 squared is equal to the other two sides squared, 153 squared plus 175 squared, and then minus 2 times 153 times 175. And then we've got to throw that cosine in it times the cosine of d. Now, this is an equation. Okay. I'm going to use Desmos to solve this. Okay. So remember, when in equations, we can do left side, right side, and see where they intersect. Now, these are going to be some fairly large numbers. So I want to show you how to manipulate Desmos to find your answer when you have really large numbers and you're dealing with trig. Okay. Now, the left side, notice it does not have a variable. So we've got to do y equals. So we're going to come right here. We're going to do y equals 201 squared. Now, you need to be doing this with me because, again, if you're not practicing, you're not going to know how to manipulate Desmos to find your answers. All right, now let's put in the right side. Okay. All right, so we've got 153 squared plus 175 squared minus 2 times 153 times 175 times the cosine, and remember we can't use d, we'll have to use x, cosine of x. So put that in Desmos real quick. Now, notice this line right here says y equals. That is your y-intercept. Our y-intercept is occurring at 40,401. All right. Well, most of the time we start off at a standard screen of negative 10 to 10, and negative 10 to 10 is our normal standard screen, but our y value is definitely not going up to 40,000. So we're going to have to manipulate our screen to get up there to that 40,000. All right. Let's see. All right, so you see how when you start coming up here and it gets really crowded and it starts acting weird when you try to manipulate it? All right, so what we're going to do is we're going to use a little bit of common sense here. Okay. We know that since we're trying to find an angle cannot be bigger than 180 degrees, right? Because the sum of all three are supposed to be 180. So adding them together should not be bigger than 180. So one angle cannot be bigger than 180. Okay. So I know my y is 40,000 and some change. I'm going to manipulate my x-axis so that I can see this stuff a little bit better. So we're going to go right here to settings. So go to your settings. All right, your x-axis. All right, I'm going to go maybe from a negative 100. And I'm going to do maybe 220. And I'm going to have it count by maybe, let's say, all right, count by tens. The step means what do you want to count by? Now the reason why I did 220 because I know the triangle cannot be bigger than 180 degrees for the sum. So that means that no one angle can be bigger than 180. So I just went a little beyond 180 on the positive side, and I just put some negative values on the left side so I could see the whole axis. Now, look how nice this is looking now. That's looking so much better. So I can actually see the y values. So we're going to keep going up here till we find that 40,000 and some change. So right here's my blue line. I'm looking to see where they intersect. Now let me make these a little bit thicker so you can see them. So to make them thicker, notice what I did. I went to the gear button. I'm going to click on the color, and right here it's got the thick lines. I'm going to do 5. Click on the my green line and do 5 right there for the thickness. Where does it first intersect? Well, it first intersects right here. So my angle, and since we're dealing with angles, we're going to do the nearest whole number. So my angle here is going to be approximately 75 degrees. So D is approximately 75 degrees. So again, why did I know to go in there and change my x values? Because my graph was looking all crazy, and I knew that my angle could not be more than 180, so I set my upper limit to 180. Now, if you notice, this changed a little bit, and the reason why it changed, remember, because after I set it, I moved it a little bit, but it made it more manageable. Okay. All right, so this is now 75 degrees. We know that. Well, what do we have now? We've got that sine scenario, the law of sine scenario, because we now know an angle and the opposite side. So let's come in here and let's do maybe angle T. All right, so we're going to say, let's label that as step 1, so this is step 2. We're going to say the sine of 75 over its opposite side of 201 is equal to the sine of T over its opposite side of 175. That's your law of sines. Sine of the angle over the opposite side equals the sine of the angle over the opposite side. We're going to cross multiply. So we get 201 times the sine of T is equal to 175 times the sine of 75. I want the sine of T by itself, so I'm going to divide by 201. All right, putting this into the calculator. All right, I've got a fraction here, so I'm going to just go ahead and throw in my fraction. Hit that division and put my fraction there. 175 times the sine of 75 over 201. All right, so we get that 0.849, etc. But notice here, we are looking for the angle. And we know when we're looking for the angle, we've got to do the inverse, right? So that means that we've got to have that little negative right there. So I'm going to come right here in the very front and do my inverse sine. So inverse sine. So here we get that T, angle T, is approximately 57 degrees. All right, so what do we know all three angles should equal? Well, we know all three angles should equal 180. Now, we'll tell you, depending on which angle you start with, you might be off by 1 or 2 degrees, however you round it. So, but as long as you're within a good range, a very good range. Okay, so to find angle H, we're going to come in here and simply say 180 minus 57 plus 75. So 180 minus the sum of 57 plus 75, and we get 48. Most of your word problems are going to be multi-step problems. So it's going to really require that you think outside of the box and think about all the different moving components that we've done and bring them together. So the first thing you always do is ask yourself, is this a law of sine or a law of cosine? If it's a law of sine, you're always going to have the scenario where you have an angle and the opposite side. If you don't have that scenario, then you want to use law of cosines, like we had to do for this original one right here. This was law of cosine because we were only given the three sides. All right. So now let's go to example 5. So we're going to put E5. All right. Airplane A is flying directly toward the airport, which is 20 miles away. The pilot notices airplane B 45 degrees to her right. Airplane B is also flying directly towards the airport. The pilot of airplane B calculates that airplane A is 50 degrees to his left. based on that information, how far is the airport? And you know what? I forgot to do the area again. Why do I keep forgetting to do the area? All right. So for the area, we've got, since we know all the information now, it should be pretty easy to do. I'm just going to go ahead and do the 1/2 AB again. So 1/2 AB times the sine of C. All right, so we're going to say 1/2. All right, let's choose two sides. So let's do 153 and 175 times the sine of the angle opposite the side I have not used. I have not used this side, so I'm going to do the sine of 75. And I would say I don't know why I keep forgetting to do, but I do know why, because it is late. And when we get late sometimes, and when it's really late, sometimes we just get a little forgetful. All right. So we got 0.5 times 153 times 175 times the sine of 75. So here our area is going to be 12,931.3. And let's see, example 3 was feet, so that would be feet squared. All right, so now example 5. And I do apologize for the little mistakes of getting the area each time. All right, so we're going to draw our triangle. All right, so again, airplane A is flying directly towards the airport. All right, so let's see if I can draw a little airplane here. And here's our airport with the lookout tower, which is 20 miles away. So the airplane is 20 miles from the airport. Okay, the pilot notices airplane B to her right. So to her right, this is airplane B. Okay, and it is 45 degrees because it was 45 degrees to her right. Airplane B is also flying directly towards the airport. The pilot of airplane B calculates that airplane A is 50 degrees to his left. Based on that information, how far is airplane B from the airport? All right, so is this a law of sine or a law of cosine? We have an angle side. Do we have enough information that we are given an angle and the opposite side? Well, yes. We know the angle right here and its opposite side, so this is going to be a law of cosines. Not law of cosines, Lord, law of sines. See, that's what happened when you stay up late. So y'all go to bed early, especially on days before a test. All right. So we're going to say the sine of 50 over its opposite side of 20 is equal to the sine of 45 over x. We're going to cross multiply and solve. And when we do that, we're going to have 20 times the sine of 45 over, this would be x times the sine of 50, but then to get x by itself, we divide. So we're going to say divided by the sine of 50. When we put that into our calculator, we're going to get x. It's approximately 18.5. And let's see, was this feet or miles? Yeah, miles. So this would be miles squared. Because remember, oh, we're not dealing with area, sorry. I just need to quit, don't I? I just need to quit. If you're wondering what time it is 1:53 a.m. So your teacher is tired. So I don't see how you teenagers do it, so that y'all stay up till 3 or 4 in the morning playing online games and then get up and go to school and concentrate the next day. Whew. All right. So moving right along, let's tackle example 6. so E6. Alright, so flights 104 and 217 are both approaching O'Hare International Airport from directions directly opposite of one another. Okay, so let's see. Let's just see if we can go ahead and start that scenario. Okay. Alright, so let's call this flight 104 and this flight 217. Okay. And they have an altitude of 2.5 miles. Now, altitude is always the vertical height. So this is 2.5 miles up, and this is 2.5 miles up. Okay, the pilot on flight 104 reports that an angle of depression to the tower is 17 degrees. All right, so we've got our tower, our airport tower. All right, so remember that the angle of depression is the angle from a horizontal down. But we also know that the angle of depression is equal to the angle of elevation. So if they're telling us that this is 17 degrees, this right here is also going to be 17 degrees. The pilot on flight 217 reports an angle of depression of 12 degrees to the tower. All right, so from the horizontal down, we've got 12 degrees, but if the angle of depression is 12 degrees, then our angle of elevation is also 12 degrees. Calculate the distance between the two planes. All right. Okay. Now, since this is an altitude, we know these right here are right angles. This triangle right here that we're trying to work with, we don't know if this is a right triangle. But we can easily figure out that it's not. Because if you think about it, all three of these angles right here should equal 180. And if we add that 12 and 17 and subtract from 180, we're not going to get a 90. So we know this is not a right triangle. However, I do see this is a right triangle and this is a right triangle. In order to use law of sine or cosines, I need to know the length of a side of the triangle here that we're trying to work with. I've got enough information right here to actually use basic right triangle trig to find the length of this one or to find the length of this one. I'm just going to go ahead and find both of them. All right, so here, in relationship to this angle right here, I've got opposite, and I would be looking for the hypotenuse. So that's the sine. So we're going to say the sine of 17 equals opposite over the hypotenuse. All right, we know that when we're looking for the denominator, we're going to divide. So let's come in here to Desmos, and we're going to say 2.5 divided by the sine of 17. And that gives us approximately 8.6. So here this is 8.6. Now that would probably give me enough information to figure this out. But I just want to go ahead and find this too, just because. Alright, here's 12. That's opposite, and that would be hypotenuse. So once again, it's sine. So I'd have the sine of 12 degrees equals opposite over the hypotenuse of h. So we're looking for the denominator, so we're going to divide again. So I'm just going to change that 17 to a 12. And this would give us 12.02, or just 12. So I now know this side and this side. I know that angle and that angle. And I've got enough information to actually find this angle right here. As I was saying earlier, we know that all three angles should equal 180. So if I say 17 plus 12, which is what, 29, and subtract that from 180, we get 151. So now what we have here is we know an angle and the opposite side, and an angle, and we're trying to find that opposite side. So this is going to be law of sines. So we're going to come right here, we're going to say, it doesn't matter if you use 8.6 or 12. Both should give you the same answer. So let's do the sine of, I'm going to do this 12 right here for the angle, over its opposite side of 8.6 is equal to the sine of 151 over the side that we're trying to find, x. Cross multiplying, we get 8.6 times the sine of 151, and then we'd have the sine of 12 times x, which to get x by itself, the opposite of multiplying by the sine of 12 would be dividing. So putting that into our calculator, 8.6 times the sine of 151 divided by the sine of 12. That gives us 20.05 or 20.1. Now, if you do it with the other side, if you did the sine of, what was it, 17 over 12 is equal to the sine 151 over x, you get 19.9, which that's still very, very close, because remember we rounded these, so that's why it would be just a little bit different, because we rounded before the end. Now I do like this problem here. Alright, just 2 more problems and we're done. Alright, we're going to look at 7 and 8, and then we'll call it a day. Now remember, anytime, you can always pause the video if I'm going too fast. Alright, so for number 7, we've got Matt measures the angle of elevation of the peak of a mountain at 35 degrees. Susie, who is 1,200 feet closer on a straight level path, measures the angle of her elevation to be 42 degrees. How high is the mountain? Alright. Okay, so we got our mountain here. Alright, so let's see, who's first? Matt. Alright, Matt's angle of elevation to the top of the mountain is 35 degrees. And then we got Susie, who is 1,200 feet closer. Her angle of elevation is 42 degrees. Okay. And they want to know how high is the mountain. So we've got to find the vertical height. Alright, so we know that we're working with either law of sine or law of cosine, and we need an angle on the opposite side. Are we given an angle on the opposite side anywhere? No. The only side we're given is this right here, and it's opposite of that angle. But do we have enough information to find that angle? Yes, we do. This is a straight angle right here, which means it's a linear pair, because it's 2 angles that make up a straight angle. Called a linear pair. Alright, this right here is supposed to equal 180. So if that's 42, 180 minus 42, it's going to give us 138. If you now notice this triangle right here, we now know 2 angles of the 3. So how can I find this missing angle right here? We can simply say 180 minus 35 plus 138, and that's going to give us 7. So this little angle right here is 7 degrees. Now I know you're thinking, well, why are we working with this triangle if we need the height? Well, because we need to be able to find a whole side. Okay, this right here is only one side of a non-right triangle. I can see that I'm eventually going to work with a right triangle because we get that perpendicular there. The altitude, the height is always a perpendicular. So if I can either find this whole side here, or I can find this whole side here, I can use basic trig to figure out what that missing height is. So what I really want, I want this right here. Oh, let's call this Z, since I called that X. Because if I can find this, that is actually the hypotenuse. So I could do opposite and hypotenuse, which would be just a regular old sine. But before I can do that, I've got to figure out if I have the law of sines or the law of cosines in this scenario. Well, I know an angle and the opposite side. So that's going to be the law of sines to start with. So we're going to come right here and say the sine of 7 over 1200 is equal to the sine of 138 over Z. Cross multiplying, we're going to have Z equals 1200 times the sine of 135 over sine of 7 times Z, but we want Z by itself, so the opposite of multiplying by sine of 7 would be dividing. And it's a 138. I put a 5, didn't I? I can't read my own writing at times. Alright, so throwing this in here, let's see, we got 1200 times the sine of 138 divided by the sine of 7. Okay, so let's just round to the nearest whole number. Get 6,589. So this is 6,589. Right, now to help you visualize this a little better, let's see what we actually have right here. I'm drawing the big triangle right here. This is 6589. This right here is 35 degrees, and we're looking for x. We've got opposite and hypotenuse, so we can just use regular old tricks. So we got the sine of 35 equals opposite of x over the hypotenuse of 6589. We're looking for the numerator, so we're going to multiply these two right here. And when you multiply these two right here, we're going to get that x is approximately 3,779. Let's see, what were the units here for number 7? Feet. So feet. So yes, these problems do involve a lot of different steps, kind of combining everything that we've done over the last few weeks. All right, and lastly, example 8. All right, so reading example 8 with me. We got a triangular playground has the sides of 475, 595, and 401. What are the measures of the angles to the nearest tenth of a degree? All right. So here's our playground. We've got what? 475, 595, and 401. Okay, we have no idea about anything with the angles. So this is definitely not a law of sines. It's a law of cosines because we got that side, side, side scenario. So that's law of cosines. All right, I'm going to start with the biggest angle. The biggest angle is opposite the longest side. So I'm just going to call this A, B, and C. Okay. All right, so I'm going to say 595 squared is equal to, all right, so this is the one I'm starting with, so it's equal to 475 squared plus 401 squared minus 2 times 475 times 401. And then times the cosine of A. Alright, so when you do left side, right side, so again, this is going to be a really big number, so I'm going to kind of remind you again how to manipulate the screen so you can find your answer easily. The left side does not have a leading coefficient, so we're going to do y equals 5, excuse me, I said leading coefficient. It does not have a variable. So we're going to say y equals 595 squared. Notice it says 354,000, so that's pretty big there. All right, the right side, we're going to put all this in exactly like it looks. So 475 squared plus 401 squared minus 2 times 475 times 401 times the cosine, and we can't use a, we're just going to use x. Alright, so we've got to get up to 354,000. Alright, so notice here, look, it turned completely red. And the reason why it turned completely red, let's see if I can break it. Watch what happens. Right before it turns completely red, see how we got all these lines? And when I keep adjusting it, they get so close that they fill the whole screen. So we want to manipulate our x. Okay, so I'm going to come right here. Oops. Didn't mean to hit the home button, but I did, didn't I? So I'm going to come right here, hit the settings button. Alright, so x. I'm thinking, alright, well, we got 475, 595, 401. Those are our sides. Then we want to talk about our angles. Again, we know all three angles should equal 180. So no one angle is going to be bigger than 180. So I'm going to go to my x-axis. I'm just going to do like negative 100 on the left side. On the left side, remember, are your negatives. And on the right side, the biggest it could be is something less than 180. So I'm going to go a little beyond 180. I'm going to say 220 again and have it count by tens. Alright, so now notice how it looks much neater. So I'm going to come up here and I'm going to find my, what was it, 354,000, which is right here. So the first value that we get to where they intersect is right here, 85. So here A, and they wanted it to the nearest tenths, I do believe, it's 85.1. So A is 85.1. Now we know an angle and its opposite side, so we can do the law of sines. So we're going to say the sine of 85.1 over 595 is equal to, let's just go ahead and do B next, sine of B over 401. Alright, so we would cross multiply and then we would divide by 595. Now, since we're looking for the angle, we would have to do the inverse. So what we end up with is the inverse of B is equal to 401 times the sine of 85.1 over, opposite of multiplying by 595 would be dividing. So let's see. Alright, so inverse sine, we've got 401 times the sine of 85.1 and then divided by 595. So we get angle B is approximately 42.2 degrees. Alright, and then finally to find angle C, we're going to say 180 minus the sum of these two angles that we just found. So 85.1 plus 42.2. We're almost done, y'all. 180 minus the sum of 85.1 plus 42.2. And we get 52.7. So C is approximately 52.7. Woohoo! We are done. Alright, so make sure that you've got your names on your notes and submit them.